All right, this is problem number 15 from chapter 6 of the Halliday and Resnick textbook. We've got this Teflon pan with scrambled eggs on it, and the coefficient of static friction between them is 0.04. And we're trying to find the smallest angle at which you could tip the pan so that the eggs will slide down, right? Okay, so here's the idea. We're going to have our pan. It's inclined at some angle. We're looking for this angle. And then here's our scrambled eggs, right? Okay. Oh, I guess they wouldn't have a yolk if they're scrambled. So let's think about what forces are on this thing. There's going to be a gravitational force pulling it down, but instead of drawing that gravitational force, let's put in our two components, right? There's going to be one component of gravity that acts parallel to the ramp, or to the pan, I guess, and then there's going to be another component that acts perpendicular to the pan. There's also got to be a normal force preventing the eggs from going through the pan, and then static friction is going to attempt to stop it. All right, so the idea is we want to find the smallest angle, theta, such that this parallel component here is greater than whatever our maximum force of static friction is. Well, so to solve this thing, let's see. Our force of static friction max, well, that's equal to our coefficient of static friction, which we know, times our normal force. Okay? So let's see, what's our normal force? Well, that's equal to this perpendicular component. So the perpendicular component is just the weight, which is mg, right, times the cosine of our angle. Okay? So that means my normal force up here is also mg times the cosine of theta. And our parallel component is equal to the weight, mg, times the sine of the angle. Okay? So, now, in order for... Okay, let me clear up a little space here on the board. Okay, so in order for this thing to slide down the ramp, what's got to happen is we have to have our parallel component of gravity has got to be bigger than our FFS max, right? So for us, let's see, our FG parallel, well, that's mg sine theta, right? That's got to be greater than this guy. Well, let's see. Let's do one other step here. So this is really our coefficient of static friction times our normal force. But our normal force is just mg times the cosine of theta. So here's my FFS max, right? So coefficient times mg cosine theta, right? So there's our equation, and we got to solve for theta, right? Right? Wasn't that our original goal? Was we wanted to find out what our theta was? So if you divide both sides by mg, those guys cancel. So I'm trying to find my angle. So let's get everything that has the angle on the same side. So I'm going to divide everything now by cosine of theta. Okay, so divide both sides by cosine, and we end up with this. Look, over here we've got our coefficient of static friction is greater than sine of theta over cosine of theta. Oh, that's just tangent of theta. So that means that theta has got to be greater than or equal to the inverse tangent of our coefficient. So find the inverse tangent of 0.04, and you get 2.3 degrees.